When we first met back in September, we defined chemistry as the study of matter, its properties, and the changes it undergoes. We spent all of first semester studying matter, how to measure it, observing it, and learning about its properties. This semester, we will be focusing on all of the changes that matter can undergo. We did introduce compounds last semester, however, we stayed away from what holds elements together in compounds. During the next 2 units, we will be studying this topic in the form of bonds. Bonding is defined as a force of attraction that holds atoms together to form compounds. Although we draw bonds typically as a line or a dash, that represents an attraction between two charged objects. So how do these atoms become charged? Well, let's look at an example. Sodium, which has 11 protons in its nucleus, and then 11 electrons in its shells, 2 in the first energy level, 8 in the second, and then 1 in the first. So this is a neutral atom with 11 protons and 11 electrons. Sodium tends to lose 1 electron though, which now we have 10 electrons. Because the protons now outnumber the electrons, the sodium atom becomes charged, and it has a +1 charge because the protons are outnumbering the electrons. This whole process of positive ion formation happens for many of the metals on the periodic table. Those yellow-tiled elements tend to lose between 1 and 3 valence electrons, giving them a positive charge. We call positively charged ions cations. So again, sodium in its ground state has an electron configuration of 1s2, 2s2, 2p6, 3s1. When sodium becomes an ion, it loses that 1 3s electron and now has a positive charge and a new configuration of 1s2, 2s2, 2p6. If you analyze the the Aufbau diagram on the right, you can also see this electron removed as the sodium forms a positive ion. Now let's look at an example of an atom that forms a negative ion in sulfur. Sulfur has 16 protons in its nucleus and then 16 electrons, 2 in the first energy level, 8 in the second, and 6 in the third. With the 16 protons and 16 electrons, sulfur is typically a neutral atom. When sulfur becomes an ion, though, it gains 2 electrons. Because of these 2 new electrons, it is going to have a negative charge because the 18 electrons are outnumbering the 16 protons. Nonmetals are the type of element that tend to gain electrons, again between 1 and 3, to produce a negatively charged ion. We call these ions anions. Again, our example was sulfur with the ground configuration of 1s2, 2s2, 2p6, 3s2, 3p4. Sulfur is going to try to fill in its 3p sublevel by gaining 2 electrons, producing a sulfur 2- ion with the new configuration of 1s2, 2s2, 2p6, 3s2, 3p6. And you can see those 2 electrons added to the Aufbau diagram on the right. Now what about ion size? When sodium loses its 1 valence electrons, this entire shell is now empty and is no longer a part of the atom. That physically makes the sodium ion smaller. Sulfur, on the other hand, although it doesn't gain an entire energy level, now because of these 2 extra electrons, the protons don't have as strong of a pull from the nucleus, and so the shells are able to move further away, producing a larger ion. Although those are only 2 examples, all ions follow that same general trend. Positive ions, which have lost electrons, are always smaller than the atom from which they were formed, typically because we're leaving an entire empty energy level, plus the protons are outnumbering the electrons, causing a stronger attraction, which will pull the electrons closer. Negative ions, on the other hand, are always larger than the atoms from which they formed. They have more electrons in that same energy level, but the protons do not exert as strong of a pull, so the shells are able to move further away and produce a larger ion. Another example of ionic size would be when lithium and fluorine come together to form an ionic compound. Lithium and fluorine are both in the second period of the periodic table. The lithium atom is larger because it has fewer protons and experiences less of a pull from the nucleus. However, when lithium loses an electron, it empties out that entire second energy level, plus the protons have a stronger pull now and will pull the final energy level in closer, producing a smaller ion. Fluorine gains an electron, so now the electrons are outnumbering the protons and are able to move further away from the nucleus. Now that we have an understanding of ions and how they form, we want to talk about how to name ions. It's a pretty easy system. The cation, or the positive ion, it still retains the name of the element. For example, when calcium loses 2 electrons to become a calcium 2+ ion, we still call it calcium. Anions, on the other hand, we change the ending of the name to "ide." So when oxygen gains 2 electrons to become an anion, we call this the oxide ion. So we talked about bonding in general as a force of attraction. Specifically, when we're talking about ionic bonding, some metal atom is going to lose between 1 and 3 electrons, which produces a positive charge, and a nonmetal atom will gain between 1 and 3 electrons, causing it to have a negative charge. Now that they are both ions, they will form a bond, or the force of attraction, that holds the two together in an ionic compound.